In this video, you will learn how to solve equations of third degree or higher, how to solve rational equations, radical equations, rational exponent equations, as well as equations in quadratic form. And then at the end, we'll explain how to use these different solving methods to work through some different application problems. So let's begin with the equations of third degree or higher. All right, so here we have our first equation of 3x cubed plus 2x squared minus 3x minus 2 equals 0. Now, when you see an equation like this where there's 4 terms total, our method of choice will typically be factoring by grouping. So what that looks like is we group together 2 terms. Many times it's the first 2 terms and the last 2 terms. So when you do that, though, just be careful with this second parentheses because there's a negative in the front. All right, so with the parentheses, whatever's in front now goes to everything in the parentheses. So originally the negative was just with the 3x, but now the negative is affecting the negative 2. So to account for that, we need to change this second sign right here to make it to be the same value. All right, so from this point, what we can do is we can pull out from each parentheses the greatest common factor. So the first parentheses here, okay, notice they both have an x squared in common. So I factor x squared out, and in the parentheses, I'm left with 3x and then plus 2. And then the second parentheses, we would try to do the same thing if possible, but here there's not a greatest common factor to pull out. So we just keep it the same as it was, 3x plus 2. That's equal to 0. But take note that there's an assumed 1 right here. So it's not written, but it's assumed. So what we can do from this point is notice that with each part, here and over here, they both have a 3x plus 2 in common. So that means what we can do is we can pull out that 3x plus 2 because that is the greatest common factor of both of those terms. So you pull out the 3x plus 2, and in the other parentheses, you put what is remaining, which is the x squared minus 1. So we have 3x plus 2 times x squared minus 1 equals 0. And we see that typed up right here. Now from here, x squared minus 1 can factor further. That is a difference of squares, and that factors to become x plus 1 times x minus 1. Now what we can do at this point is we can use the zero product principle to set each part equal to 0. So either x plus 1 equals 0, x minus 1 equals 0, or 3x plus 2 equals 0. We solve each of those equations, so we get x equals negative 1, x equals positive 1, or negative 2 over 3. So we have three answers, 1, negative 1, or negative 2 over 3. So that is our first method or first type of equation that we're going to work with. And the second type would be rational equations. A rational equation would be an equation that has a rational expression. So rational meaning a fraction of some sort. So these ones can be kind of messy to work with. So what we need to do basically is we need to multiply every term, every part of the equation, by the least common denominator. So that is our objective, okay? When we do that, that will get rid of all the fractions so that from there we can solve with one of our other methods. So what we need to do is find that least common denominator. So the x cubed plus 5x squared, that can factor. So we want to do that first for every fraction, factor if possible. We can pull out an x squared. You're left with x plus 5 in parentheses. All right, so that would be that part. And then over here we have x plus 5, and then we have x squared. So we have x squareds, and we have x plus 5s. And the most we see at one time is going to be 1 of each. So what we do is we take 1 of each, put it together, and that is our least common denominator. Okay, so that's going to look messy on this next part because we're going to take this equation right here, and you're going to multiply by x squared times x plus 5. So that's what we see right here on the left side, x squared times x plus 5 multiplied by the left side. and then the x squared times x plus 5, you multiply on the right side. Okay, so on the left side, x squared times x plus 5, remember that is the same thing as x cubed plus 5x squared. That was the factored form. So that would actually cancel out with this denominator right here when you multiply. That leaves you with a 5 on the left side. On the right side, okay, we need to multiply x squared times x plus 5 to both terms in the parentheses. So ideally, you can do this in your head, but if not, you can write it out. So we'll write it out so you can visualize what's happening. We have 4 over x plus 5 times x squared times x plus 5. So what happens is the x plus 5's cancel. What you have left is 4 times the x squared, or 4x squared. And then you can do the same thing. You take the x squared times x plus 5, and you're multiplying it by the 1 over x squared for the other part. When you do that, the x squareds cancel. You have 1 times x plus 5, or just simply x plus 5. So that's a plus sign in between. So what we have now is 5 equals 4x squared plus x plus 5. So it looks messy right there at that one step, but once you have the fractions cancel out, notice the equation is much, much simpler to work with. And we see that typed up right here. So that was our objective, was to get rid of the fractions. Now from here we can solve. So we can set it equal to 0. Let's bring the 5 to the right side by subtracting. So subtract over here. 5 minus 5 gives you 0. So what we have is 4x squared plus x on the right and 0 on the left. So on the right side we can factor. They both have an x in common. So you pull an x out, you're left with 4x plus 1 in parentheses. And now we can use the zero product principle, where we have either x equals 0 or 4x plus 1 equals 0. So x would equal 0, or solve the other equation, and you would get negative 1 over 4. So we have two possible answers, but with any fraction equation, any equation with fractions, we want to double check our answers by plugging back in quickly, specifically into the denominator, because our denominators can never equal 0, because if it's equal to 0 in the denominator, the answer is undefined. So if you plug a 0 back in, let's say you plug it in right here for x squared, we have 0 squared, which is 0, and that makes that whole thing undefined. So because of that specific part right there, 0 is not a solution because it makes it undefined. You could try the other answer, negative 1/4. You can plug it in and there's going to be no problems with that one. So our answer would be only negative 1/4. So it's good to get in the habit of plugging back in, because you will find that sometimes one of the answers will not work. Next we have radical equations. So a radical equation is an equation that has a radical expression, so something with a square root. Here's our first example, and basically with radical expressions, we want to get rid of the radical as quickly as possible. So we can do that by isolating the radical on one side and then squaring both sides. So like right now, if we square the left and square the right side, squaring the left will get rid of the radical, right? Because those are inverse operations. So on the left, we would have 2x minus 7. On the right, don't forget when you have x minus 3 squared, that is the same thing as x minus 3 times x minus 3. So that would give you x squared minus 3x, and then plus 9, which would be x squared minus 6x plus 9. So don't forget that. Some people will forget that middle term, so be careful on that. And the shortcut, by the way, which will be helpful at times, if you're squaring a binomial, you take the first term and you square it, so like x squared. You take the last term and square it, negative 3 squared, to get negative 9. And then you multiply the terms and double it. So negative 3 times x times 2 gives you negative 6x for that middle term. So that shortcut will be helpful at times to remember. Now from here, the radical is gone, and we have a quadratic equation. that we can solve with one of our methods. So either the factoring or completing the square or the quadratic formula. So we want to set this equal to 0. Ideally, factoring would be our method of choice. So let's try that first. So we can subtract 2x from both sides. Then we can add 7 to both sides. That gives you 0 on the left. And on the right, we'd have x squared minus 8x plus 16. From here, this right side will factor out. We have x minus 4 times x minus 4 equals 0. So set each part equal to 0. So x minus 4 equals 0, or x minus 4 equals 0, which would be the same thing. So we only have one answer, really, and that's going to be x equals 4. So we can see that all typed up right here. And by the way, it's always important to check your answers with these type as well, because sometimes your answer will actually not work. So we go through all the steps, and there's times when even still the answer will not work. All right, so if you plug it back in, we'd have 2 times 4 minus 7. So the square root of 2 times 4 is 8, minus 7 is 1. So the square root of 1 equals, and then 4 minus 3. So this one would work because that would equal 1 on the left and 1 on the right. So that does work out, so 4 would be our correct solution. Now let's try another example. This one, we will increase the difficulty. Here we have two different radicals in the same equation. So the technique we want to use for this one is we want to separate the two radicals. So we have one on the one side of the equation and the other on the other side. So what we can do is we can let's try this one, bring it over to the left side. We do that by adding. So if we add the square root of 10 minus x on both sides, on the right it would cancel. And on the left, we would have plus the square root of 10 minus x. So on the left side, we have 2 plus the square root of 10 minus x. And on the right side, we have just the square root of 3x minus 2. So from here, what we can do is we can square both sides of the equation. What that does for us is on the right side, the square and the square root will cancel out. And that leaves you with 3x minus 2 on the right. Now the left side, be careful, all right, because we mentioned when you square a binomial, the shortcut is we square the first term, so 2 squared is 4. We could square the last term, so we square the square root of 10 minus x, which would get rid of that radical. So we have just 10 minus x right there. But then the middle term we find by multiplying the two terms, so 2 times this, and then double it. So 2 times 2 is 4 times the square root of 10 minus x. And right here is typed up with what we have at this point. All right, so what we have done is we have gotten rid of one of the radicals. Now we just have one more to take care of. So it's kind of like doing the same thing twice. All right. So what we can do is now we can take care of this radical term like we did over here with our first example. We want to isolate that radical term. So here we have 4 plus 10 is 14. So we can bring it to the right side by subtracting 14. Right, that'll get rid of the 4 and the 10. Okay, so we subtract 14 to bring it to the right side. So what you have now would be the 4 times the square root of 10 minus x, and then minus x here. Actually, let's bring the x over as well. So we add x to both sides to bring it over. So we have that equals 3x plus x is 4x, and negative 2 minus 14 is negative 16. So we have this. We could actually square right now, but since we can divide everything by 4 first, let's do that. So you could have squared right here, but the numbers would have been bigger. So if you square, or if you divide by 4, we now have the square root of 10 minus x on the left equals x minus 4 on the right. And we see that typed up right here. Now from here, we've isolated that radical term, so we can get rid of the radical by squaring both sides. If you square both sides, The square and the square root cancel out. You have 10 minus x on the left. And then on the right, when you do x minus 4 squared, we square the first term to get x squared, square the last term of negative 4 to get positive 16. Multiply and double, negative 4 times x times 2 is negative 8x for the middle term. So now we can set it equal to 0 and hope that it factors. So we can add x to both sides. That'll cancel on the left. Subtract 10 on both sides. We are left with 0 on the left, x squared, and then negative 8x plus x gives you negative 7x. 16 minus 10, that gives you a positive 6. And we see that typed up right here. Now the right side does factor, so we can use our zero product principle to solve this quadratic equation. This factors to get x minus 6 times x minus 1 equals 0. So with that being said, either x minus 6 equals 0 or x minus 1 equals 0. So we solve, x would equal 6 or x would equal 1. So we have two different answers, and we always, again, want to double check by plugging back in to the original equation. So if we plug a 1 in back into the equation, we would have 2 equals the square root of 3 times 1 minus 2. So if we plug a 1 in there, we have 3 minus 2, which is 1. And then minus the square root of 10 minus x, so 10 minus 1, that gives you 9. So we have 2 equals 1 minus 3. Notice that is not a true statement. So because of that, x equals 1 does not work. If you plug a 6 in, it would work. We would have 18 minus 2, which is 16. So we would have 2 equals the square root of 16, which is 4, minus 10 minus 6 is 4, so the square root of 4 is 2. 2 equals 4 minus 2, that one does work. All right, so 6 does work, the 1 does not. So the 1 is what we would call an extraneous root. It's extraneous. It's an extra one that does not hold true. All right, so we don't include that one because it's extraneous. It's extra, it does not work. So your final answer would just be 6. So this is radical equations. Next we have what is called rational exponent equations. So this would be something where your exponent would be a fraction. So here's maybe hard to tell typed up, but this is x to the 3/2 power. So 3/2 is your exponent. So for these type of equations, what we can do, our technique, is going to be we want to raise both sides to some power. And the power we raise it to is going to be something so that on the left side, your final answer would be x to the first power, or just x. So to do that, we can raise both sides to the reciprocal power. So the reciprocal of 3 over 2 is 2 over 3. So we do that, and on the left, when you have a power to a power, you multiply the exponents, and the reciprocals multiply together will just give you 1. So we have x to the first power on the left. And then on the right, we just have to figure out what is 125 to the 2/3 power. So at this point in the game, you probably could just use a calculator, but if you do it by hand, you can do it pretty quick as well. So the 125 goes inside. The 2 would be your exponent. It can go either with the 125 inside, or it could go here on the outside. And the 3, the denominator, will always be your index. So this is what we have, and the cube root of 125 is 5, because 5 times 5 times 5 is 125. So we have 5 and then squared, and that equals 25. So your answer for x is x equals 25. And we see that typed up right here. Let's try another example and see if you can do this one on your own as best as possible. But here, notice what we have is something a little bit different, because now we have a 1 and we also have a 2 for the coefficient. So our method of solving is going to be the same way you would any equation. We get x by itself, and you work in reverse order of operations. So we can take care of the addition of the 1 by subtracting. That gives you 2 times x to the 2/3 power equals 8. Next, we take care of the multiplication. So we can take care of that by dividing both sides by 2. And then lastly, we take care of the exponent. So again, our technique is, once we get to this point, we can raise both sides to the reciprocal power, which would be the 3 over 2 power. On the left side, that would give you x, because 2/3 to the 3/2 power, that cancels to give you 1. And so we have x equals 4 to the 3 over 2 power. So what that is equal to, you can plug it into your calculator or realize that this can be translated as a radical. 4 goes on the inside. The 3 can go with the 4 inside or outside. This one we can put it here inside. It's going to be pretty simple. And the 2 is your index. So 4 cubed would be 64. So we have the square root of 64, and that would equal 8. So your final answer is x equals 8. So we see it all typed up right here. And notice it's actually the absolute value of x would equal 8, making 8 either positive or negative. So we actually have two answers. And the reason is because if you look back at the original equation up here, okay, look at this rational exponent. So what that means is whatever x is, okay, whatever x is, we have to square it and then take the cube root of that. So the squaring process will take whatever x is and make it positive. So even if it's a negative 8, by squaring it, it becomes a positive 64, right? And then you take the cube root of that, and that gives you a positive 4. All right, so that's the reason, is because the squaring will make it into a positive no matter what. So it could be a positive or negative 8. So basically, if this, this numerator here is an even number, it's going to not matter the sign. It could be positive or negative, because it's going to change it to positive no matter what before you take the root. Here we have a third example to try. All right, so let's try this one out. So again, we want to solve by isolating the variable so we can work in reverse order of operation. So we take care of subtraction first by adding. So we add 7 to both sides to get 2x to the 5/3 power equals 486. And then get rid of the 2 being multiplied by dividing. So now we have x to the 5/3 power equals 243. And we see that typed up right here in the notes. And then to finish off, we need to get rid of the rational exponent. And again, the process we want to use is we want to raise both sides to the reciprocal power, which would be the 3 over 5th power. So on the left side, 5/3 times 3/5 for the exponents would cancel and give you 1. So we have x to the first power on the left, and then we have 243 to the 3/5 power on the right, which, remember, 3/5, that exponent you can write as a radical. So the 3 can go with the 243 on the inside or on the outside, and the 5 is going to be your index. So this one, maybe some trial and error or use a calculator, but the 5th root of 243 would actually be 3, because 3 to the 5th power is 243. And then that's raised to the 3rd power, so 3 to the 3rd power would be 27. So your final answer is 27, and that would be for this equation. The next type of equation to look at are equations that are in quadratic form. Now this can take different forms. It can look differently with different equations. So we're going to look at 2 different types, and again, it could be even different than these 2 that we're showing. But the first kind here, we have 3x to the 4th power minus 8x squared minus 16 equals 0. And what we're doing is we are taking an equation that is not necessarily quadratic, and making it into a quadratic equation. So in this case, what we're going to do is we use a process called U substitution. Okay, U substitution, where we are substituting U in place of whatever this middle part is right here. So in this particular case, the U would be x squared. So U equals x squared, and what we can do is we can take this little equation, square both sides, and we see that u squared would equal x to the fourth power. So we can replace this x squared with u. So now we have minus 8u, and replace x to the fourth power with u squared. So we have 3u squared. And that gives us 3u squared minus 8u minus 16 equals 0. So this is temporary. We are substituting the u in place of the x squared, because now what we have is a quadratic equation that we can solve. So we see our equation typed up right here. And at this point, we can solve by different methods, but factoring would work fine. And that would give us 3u plus 4 times u minus 4 equals 0. And then from here, we can use our zero product principle, where we can set each part equal to 0. So 3u plus 4 equals 0, or u minus 4 equals 0. So that means u would be negative 4/3, or u would equal positive 4. So we have solved that equation right here that we created, but we're not done yet, because the initial equation up here had x's and x squareds. So what we need to do is we need to back substitute. So in place of the u down here, we need to plug back in the x squared. So put back in x squared for u. We get x squared equals negative 4/3, or x squared equals 4. We can then take the square root of both sides of both equations. So we have x equals plus or minus the square root of negative 4/3. Or take the square root of the other equation. We have x equals plus or minus the square root of 4, which would be 2. Looking at the square root of negative 4/3, we can simplify and rationalize this radical. We can pull out the imaginary component. So we have I times the square root of 4 over 3. We can break it apart. So now we have the square root of 4 over the square root of 3. Square root of 4 is 2. And we have the square root of 3 on the bottom. And we need to also get rid of that 3, that radical in the bottom. So we can multiply top and bottom by the square root of 3. So now we have I times 2 times the square root of 3, and that is over 3. All right, so that radical, the plus or minus the square root of negative 4/3, would be plus or minus, and the I can go actually right here in between the 2 and the 3. So we have plus or minus 2i times the square root of 3 over 3. And then we have a positive or negative 2 as well. So we have 4 answers. We have the plus or minus, that radical expression, then we have a positive 2 or negative 2. So that is just one way the equation may look. It may have x squareds and x to the fourth powers. Here's another type you might see. And here we have rational exponents. So again, if it looks something like this, or something that is not quadratic in nature, we can make it quadratic many times by using the u substitution. So here we can let u equal this middle part of x to the 1/4 power. If that is true, then u squared would equal x to the 1/4 squared power. So what's 1/4 to the second power? We multiply the exponents, 1/4 times 2, to get 2/4, or 1/2. So all that to say that this x to the 1/2 power is the same thing as u squared, and then minus 3 times, and in place of x to the 1/4 power, we're plugging in the u. So now we have our equation, and it's quadratic, so we can try to solve by factoring, or completing the square, or the quadratic formula. This one we'll solve by factoring. So you can factor the left side to get u minus 2 times u minus 1 equals 0. So u minus 2 equals 0, or u minus 1 equals 0, which means u would have to be 2 or 1. Now from here we can finish off by back substituting. We can put back in this x to the 1/4 power in place of u. So now we have x to the 1/4 power equals 2, or it could equal 1. And then from here we can get rid of that rational exponent and solve for x by raising both sides of both equations to the reciprocal power of 1/4, which is the 4th power. So raise both sides of both equations to the 4th power. We now have x on the left, 2 to the 4th power, which is 16 on the right of that first equation. Second equation, x to the 1/4 power to the 4th power, again, would give you x to the 1st power. And then 1 to the 4th power is just 1. So here we have two different answers. X could be 16, or x could equal 1. All right, so we've worked through different types of equations that you will need to know how to solve. And now to finish off the lesson, we will work with some application problems. So here, our first application problem says both Jim and Tyler are traveling to the beach, which is 200 miles away. Jim cannot leave until an hour after Tyler leaves, but he travels at an average speed of 10 miles an hour faster than Tyler. If they arrive at the same time, what are Jim and Tyler's average speed? So for word problems, many times it's helpful to kind of write out the information. So we have Jim and we have Tyler. So two different people, and we're dealing with distance and speed and time. So we're going to want to use our distance formula of distance equals rate times time. Now there's different ways we can approach this, but using this formula, one way of approaching is we can rearrange this formula as needed. And in this case, if we rearrange and solve for time, time would equal distance divided by rate. All right, so with that being true, all right, looking at Tyler, Tyler's rate can be our variable. All right, so because Jim's rate is based off Tyler's rate, right? Jim is traveling 10 miles an hour faster than Tyler. So if you look at Tyler, the distance was 200 miles, right? So we do 200 divided by the rate. The rate we'll call R. Okay, R for rate. For Jim, okay, it's going to be the same kind of idea. The distance is 200. His rate is going to be 10 miles an hour faster than Tyler. So if we do R plus 10, that's going to be his rate. So looking at these times, okay, these are the times for Jim and the time for Tyler. Okay, we can actually relate this information into an equation. Okay, so if we take those rates, so we have Jim and we have Tyler. Okay, we know that they are close to being the same, but they're not quite, because their times, it says Jim cannot leave until an hour after Tyler leaves. So this was Jim. This was Tyler. Their times are not equal, but Jim is leaving an hour after Tyler. All right, so that means Jim is traveling an hour less than Tyler. So if we subtract 1 from Jim's time, now that's going to be equal. And actually that was backwards. We need to put -1 over here. And this is really probably the trickiest part, is understanding or figuring out where to put that subtraction. It's easy to get it backwards. The way I personally think through this, and the way I caught my mistake, is if I just plug in actual numbers. So Jim leaves an hour after Tyler. So Tyler's traveling for a longer period of time. So let's say Tyler travels for 5 hours, Jim travels for 4 hours. Okay, that would be a true statement, right? That would work in theory, because Jim is traveling an hour less than Tyler. And the way to make this equal would be by subtracting 1 from Tyler's time. Okay, that's the only way to make this equal. So that's why it's going to be -1 for Tyler's time over here. So be very careful with that. That is definitely the trickiest part, is figuring out where to put that -1 to make these equations even. But again, that's my thought process. You can plug in actual numbers just to kind of figure out where that minus would have to go. And we see that all typed up right here, where this is our equation. So this is a rational equation, so we can use our technique for solving these types of equations, where we multiply everything by the least common denominator. So we have r's and we have r plus 10s. So our common denominator would be r times r plus 10. All right, so you're going to multiply every term by that. So on the left side, that part, and the right side, both terms over here as well. So for the left side of the equation, the r plus 10s would cancel. You're left with r times 200, or 200r. On the right side, the first term, the r's would cancel. You're left with 200 times r plus 10. And then minus 1r, so minus 1r times r plus 10. And we see that typed up right here. Now at this point, we can start trying to simplify and setting equal to 0. So let's distribute over on that side. So left side is 200r. Here we get 200r when we distribute. 200 times 10 is 2,000. And then negative r times r is negative r squared. And negative r times 10 is negative 10r. Alright, so from here we want to set equal to 0. We want the r squared term to be positive. So let's bring everything to the left side to make that happen. So if we subtract 200r to bring it to the left side, that actually cancels out right away. So now we have 0 equals 2,000 minus r squared minus 10r. What we can do, let's just actually, instead of bringing everything to the left, multiply everything by negative 1, which will have the same effect as bringing everything to the left side. So basically just change the signs to get r squared, positive 10r, and then negative 2,000. So we could do it that way, or we could take the time and add and subtract everything to the left. Either way, we get this equation right here. So we see that typed up right here. And now we could use completing the square, factoring, or quadratic formula to solve. So in this case, we'll probably want to use quadratic formula to solve. And so if we do that, you plug in the numbers into the quadratic formula. So we have r equals the opposite of b, so the opposite of 10, plus or minus the square root of b squared. So it's going to be 10 squared, which is 100, minus 4 times 1 times negative 2,000, 4 times a times c, which would give you positive 8,000. And then all that over 2 times a, which is 2 times 1. So inside the radical, we get 8,100, and you take the square root of that. That's going to be plus or minus 90. So we have negative 10 minus 90, which is negative 100 over 2, which would be negative 50, but that doesn't work because a rate cannot be a negative. So then we do the other one, negative 10 plus 90, which is 80 over 2. That gives you a rate of 40. So r is 40, which was Tyler's rate, right? Tyler's rate was 40, was r. And then Jim's rate was r plus 10, which is 40 plus 10, or 50 miles per hour. And if you want, you can double check by plugging back into the equation. Right here, 200 divided by 40 for Tyler gives you 5 hours of travel. Jim's time, 200 divided by 50, gives you 4 hours of travel. So the time is only 1 hour apart, which is what we wanted initially. So we do have the correct solution. Tyler was 40 miles an hour, Jim was 50 miles per hour. Let's take a look at one more application problem. Here we are told that the number of bacteria in a swimming pool after disinfection can be modeled by this equation right here of y equals 5,500 times the square root of 0.025x plus 0.1, where x is the number of minutes passed. At what time are there 3,000 bacteria left in the swimming pool? So what we need to do is we need to take the initial equation, and 3,000, that is the number of bacteria, which is represented by the letter y. So you plug a 3,000 in for y, and then we can solve for x, which is the number of minutes that was passed. And that's what we're trying to find, right? At what time are there 3,000 bacteria left? So we solve this for x, so we can use the process for the radical equations, where we isolate the radical term, get rid of the 5,500 by dividing both sides by 5,500. When you do that, on the right, that cancels. 3,000 divided by 5,500 gives you 0.5454. Now we can get rid of the square root by squaring both sides. On the left side, that would give you 0.2975. On the right side, we would just have the 0.025x plus 0.1. Now from here, we can solve like normal. we can bring this, well, actually, let's bring the 0.1 to the left side by subtracting 0.1. That gives you 0.1975 on the left, and then we have 0.025x on the right. And then from here, to solve for x, we can divide both sides by the 0.025. That will get the decimal to cancel on the right. And then 0.1975 divided by 0.025 on the left would give you 7.9. So the answer is 7.9, and that is minutes, and that can round to approximately 8 minutes. So about 8 minutes have passed when there are 3,000 bacteria left in the pool. And that concludes our lesson for today. We will see you next time.